We've already looked at a quadrilateral, and we know that a quadrilateral is a four-sided figure. So we're going to talk about a special quadrilateral today, and that's parallelograms. And first we need to define what a parallelogram is. Well, one, we know it's a quadrilateral. So it is a quadrilateral in which both pairs of opposite sides are parallel. And if I wanted to draw a diagram of a parallelogram, we would put these parallel markings. So I know that that is a parallelogram, and that is my overarching definition, is that both pairs of opposite sides are parallel. Now, that's the definition. There are four properties of every parallelogram, okay? The first one is that opposite sides are congruent. So I can make this marking. Opposite sides are congruent. Okay? I can say that opposite angles are congruent. And I'll do that with a different color. So opposite angles are congruent. I also know that consecutive angles are supplementary. And you know that because two parallel lines cut by a transversal, consecutive interior angles. So these are still consecutive interior angles, and then we know that they are supplementary. One other property is that diagonals bisect each other. So here's what that means. If this is a diagonal and this is a diagonal, it's cutting this diagonal in half and it's cutting this diagonal in half. So they bisect each other. So every parallelogram has these four qualities to them, okay, four properties. And then, of course, my overarching definition. So let's take a look at how to solve them algebraically. So let's move that up a little bit. Okay, and let's take a look at numbers 1 and 3. So if AB is 15, I know DC is 15. Opposite sides are congruent and parallel. I know that's 8. I know this is 68 degrees because of opposite angles are equal. And I know that these are supplementary, so this is going to be 112 degrees. Opposite angles are congruent, so that's 112 degrees. So let's go ahead and fill in the blanks here. AD is 8. DC is 15, angle A is 112 degrees, angle B is 68 degrees, and angle C is 112 degrees, okay? So that's how I'm getting the measurements there. Now, if I look at number 3, RS is 27, so UT is going to be 27. Opposite sides are congruent. If RU is 18, I know that ST is 18. It says it's looking for the length of VS. Well, if my diagonals bisect each other, I know this length is congruent to this length, so VS is going to be 7. And then VT is going to be 15 because RT here to here is 30. So if this one bisects it, it cuts 30 in half, making it 15. So that's what those properties allow you to say algebraically. Let's do a couple more together. All right, let's take a look at number 6, shall we? All right, so GHF is 34 degrees. I know that HJF is 124 degrees, and FKJ is 79 degrees. So you still have parallel lines cut by transversal, alternating interior angles. You still have vertical angles. You still know that a triangle is 180 degrees. So knowing all those qualities, you can still, along with our new ones, we can still fill in the blanks. So if you look at GFJ, well, if this one's 124, these guys are going to be supplementary to each other. So this one is going to be 56 degrees. Okay? GFJ is 56 degrees. If I'm looking for FGH, I know that these angles are opposite each other and opposite angles are congruent, so that one's going to be 124 degrees. If I'm looking for HFJ, I know that these guys are going to be alternating interior angles, so this one is going to be 34 degrees. If I'm looking for HKJ, I know that these guys form a linear pair, so they're 180 degrees, they're supplementary, so this guy is going to be 101 degrees. If I'm looking for JGH, if this is 79 and this is 34, that's going to allow me to solve for this piece right here. So 79 plus 34 plus x all equals 180 degrees because we have ourselves a triangle. So that means that's going to be 180, 9, 10, 113 plus x equals 180. And so x is going to be 67 degrees. So this angle is going to be 67 degrees. So I know this angle here is going to be 67 degrees because of alternating interior angles. If I'm looking for FHJ, I can do the same thing. This is 67 degrees. Opposite angles, I have, let me see, hang on my 67, 34. Vertical angles makes this 79. I know that this is 101 degrees. I know this is 67, so this angle here is 124 minus 67 gives us this angle. So I get 57 degrees. So if this is 101 and this is 57, I know 180 degrees make up a triangle. So this together is 158. So this has to be 22 degrees. So FHJ is going to be 22 degrees, and I skipped over FGH. Sorry, FGJ. Oh, I'm looking for this one. Okay, so alternating interior. If that's 57, this guy is 57. Alternating interior angles. And then GJF, we already found was 67 degrees, and we found that earlier on, so that one is 67 degrees. So that's kind of how we piece everything together. You just take it one step at a time, and we're just putting all those properties together to solve for that parallelogram. And then, of course, when you bring some algebra into it, you're just setting your equations up. So let's take a look at number 13. If KLH, if this whole angle is 134 degrees, okay, and I want to solve for x, well, what do we have to know here? There's a couple of things. I know that these guys are alternating interior. So if this one's 25 degrees, this one is 25 degrees. Now I have all of these angles identified right here, and I know that angle L and angle K together are supplementary, which means they're 180. So I can say that 4x plus 9 plus 25 plus 134 all equals 180 degrees. Do you guys see how I'm setting that one up? So then, when I combine, I get 4x 34 plus 168 equals 180. When I subtract 168 from both sides, I get 4x equals 12, and then x is going to equal 3. And I'm solving for x, so x, of course, then equals 3. So we're using the same knowledge that we would to put it in algebraically. If you need help on that, just let me know.